All right, welcome back everybody. Here we are. This is video number 2 for AP Calculus BC, section 10.11, Finding Taylor Polynomial Approximations of Functions. We left off at the end of the first video having just found our first Taylor polynomial, the Taylor polynomial for y equals the natural log of x, centered at x equals 1. And we said we were going to look at what the graph of y equals natural log of x looked like in comparison to this polynomial. So what we're going to do here, I'm going to go ahead and pull up this graph. Here's the graph of y equals natural log of x. And right there you see the curve at x equals 1 is right here on our screen. So let's look at the first order polynomial, y equals the quantity x minus 1. Okay, so notice this curve has the same function value, and it also has the same derivative as this curve at x equals 1. So let's add the next term. That was minus the quantity x minus 1, quantity squared, all over 2. And you see that this does an even better job of approximating the function y equals the natural log of x close to 1. It's really close. And then we add another term, quantity x minus 1 to the third over 3. Look at how nice of a job that does of approximating the curve around where x is 1. And I can zoom in on this and you see that it's really close when we're close to 1. And as I add each additional term, this becomes a better and better approximation of the function y equals natural log of x. And so if we add more and more terms to this, we're going to do a better and better job of approximating y equals the natural log of x. How good? Well, you'll see that more as we move into future lessons. All right, example 3 from our lesson. Find the third degree Maclaurin polynomial for f of x equals e to the 3x. Then find the values of f of 0.2 and p of 0.2 to compare their values. So in this case, we're looking for the Maclaurin polynomial. So that means we're looking for the Taylor polynomial at x equals 0. And so we want our third degree polynomial, which is going to be the value of f at 0 plus the value of f prime of 0 times x plus f double prime of 0 times x squared all over 2 factorial plus f triple prime of 0 times x cubed all over 3 factorial. All right, so we start f of x is equal to e to the 3x. So f of 0 is equal to e to the 0, which is 1. Then I find f prime of x. That's going to be 3e to the 3x. So f prime of 0 is going to be equal to 3. F double prime of x is 9e to the 3x. So f double prime of 0 is going to be 9. And f triple prime of x is going to be 27e to the 3x. And so f triple prime of 0 is going to be 27. Man, it was really nice how simple those derivatives were to get them for our polynomial. And now that I have the value of the function and its necessary derivatives, I can write the third degree Maclaurin polynomial for this function. And that's going to be p sub 3 of x is going to be equal to f of 0 plus f prime of 0 times x plus f double prime of 0 x squared over 2 factorial plus f triple prime of 0, which is 27 over 3 factorial. So that's 27 over 6. I'm going to go ahead and reduce that a while. And 27 over 6 reduces to 9 over 2. So this is our third degree Maclaurin polynomial for f of x equals e to the 3x. And now I'm going to find the values of f of 0.2 and p of 0.2 to compare their values. So f of 0.2 is going to be equal to something, and p of 0.2 is going to be equal to something. And I'll break out my calculator to go ahead and do that. All right, let's see. I want e to the 3 times 0.2. And that's 1.822. So that's f of 0.2, 1.822. And then p of 0.2, I'm going to put 0.2 in here for x. So that's going to be 1 plus 3 times 0.2 plus 9 halves times 0.2 squared plus 9 halves times 0.2 cubed. And we get 1.816 as the polynomial approximation. And so we're only off by 6 thousandths right here, using a polynomial only up to the third term. As we add more terms, our polynomials will get more accurate in their approximation. But there we go, that was example 3. Example 4. Find the 4th degree Maclaurin polynomial for f of x equals cosine of x. All right, so 4th degree, so we're looking p sub 4 of x, which is going to be f of 0 plus f prime of 0 times x. Again, we're looking for a Maclaurin polynomial, so it's centered at 0. We got f double prime of 0 over 2 factorial times x squared plus f triple prime of 0 over 3 factorial times x cubed plus the 4th derivative at 0 over 4 factorial times x to the 4th. That's going to be our 4th degree Maclaurin polynomial. And now I need the values of the functions, of the function and its derivatives. F of 0 is equal to 1. F prime of x is equal to the derivative of cosine of x is negative sine of x. So f prime of 0 is equal to 0. F double prime of x is equal to negative cosine of x. So f double prime of 0 is equal to negative 1. F triple prime of x is equal to sine of x. So f triple prime of 0 is equal to 0. F quadruple prime of x is equal to cosine of x. F quadruple prime of 0 is equal to 1. And so now I can fill all these values in to find my 4th degree Maclaurin polynomial. It's going to be f of 0 plus f prime of 0 times x plus f double prime of 0 over 2 factorial times x squared plus f triple prime of 0 over 3 factorial times x cubed plus f quadruple prime of 0 over 4 factorial times x to the 4th. And cleaning this up, we end up with our 4th degree Maclaurin polynomial, which is going to be 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. And so that is the 4th degree Maclaurin polynomial for cosine of x. All right, do I have time for one more? Yeah, I think I've got time for one more in this video. Find the 4th degree Taylor polynomial. Now we're doing a Taylor polynomial at x equals pi over 4. And so when I go to write this, this is going to be a lot more complicated than the Maclaurin polynomials that we were just doing. I'm going to start with f of pi over 4, and then plus f prime of pi over 4 times x minus pi over 4. Plus f double prime of pi over 4 over 2 factorial times x minus pi over 4 quantity squared. So that's how we deal with it when we're working at a different center other than 0. We're going to find the value of the function and all its derivatives at that value. And we're also going to have to make the adjustment where we're taking the quantity x minus a or x minus c and raising it to that power instead of just having x raised to that power. All right, so there's our general form of what we're looking for in the 4th degree Taylor polynomial. Now we just need to find the function and all its derivatives at those values. So we've got f of pi over 4. It's the sine of pi over 2, which is equal to 1. Now f prime of x is 2 cosine of 2x. And so f prime of pi over 4 is 2 cosine of pi over 2. The cosine of pi over 2 is 0, so this is 0. And then f double prime of x is going to be equal to negative 4 sine of 2x. And so f double prime of pi over 4 is going to be negative 4 times the sine of pi over 2, so that's going to be negative 4. And then f triple prime of x, that's going to be negative 8 cosine of 2x. And f triple prime of pi over 4 is going to be equal to 0, because cosine of pi over 2 is 0. And then the fourth derivative at x is going to be 16 sine of 2x. And so the fourth derivative at pi over 4 is going to be 16. And then what I'm going to do is I'm going to substitute these into the general template for the polynomial, and I'm going to figure out and clean that up. And so doing that, we have that the fourth order polynomial is equal to f of pi over 4 plus 0 times the quantity x minus pi over 4 plus negative 4 over 2 factorial times the quantity x minus pi over 4 quantity squared plus f triple prime of pi over 4 over 3 factorial times x minus pi over 4 to the third plus f quadruple prime of pi over 4. Oops, let's replace that with what it's equal to. It's equal to 16. And so that's 16 over 4 factorial times x minus pi over 4 to the fourth. And now I'm going to go ahead and clean this up. And there we've got our fourth degree. Oh, that's not going to be, that term's going to drop out, the x term, or the x minus pi over 4 term. And this, when I simplify it, gives me 2. So this is minus 2 times x minus pi over 4 quantity squared. This simplifies to 0. And this simplifies to 16 over 24, which reduces to 2/3. And there is the fourth degree Taylor polynomial for f of x equals sine of 2x at x equals pi over 4. All right, that'll be it for this video. We'll come back and hit a third video, I believe, on this topic. Yeah, we'll hit a third video on this topic where we'll do some more examples with Maclaurin and Taylor polynomials. And hopefully then we'll wrap up this section. All right, until then, have a great rest of your day, everybody. We'll see you next time. Bye-bye for now.